Um, all right, good evening. Trust you had a good day today, and I believe you must have gone through yesterday's video to see how we began certain problems and ended them. All right, let's take a few more examples today as regard the trigonometric ratios. So let's say I have something like, let's say I say if cot theta is equal to 5/12 and theta lies between 0 and 90. That's of course acute angle. Find I sine square theta I cos theta minus sine theta. Let's solve these two first, then we'll see how far we can go. Now, recall that we said that this cotangent is inverse of tangent. Okay. Now, remember that trig ratios, the basic ones are tangent and cotangent. Sorry, tangent, sine, and cosine. All right. So that means cotangent is derived from tangent, and cotangent is inverse of tangent. That means in this place, if you want to work, you're going to bring this to tangent and not cotangent, because basically trig ratio does not involve cotangent. Okay, so converting this to tangent is going to be 12/5. Since the inverse of tan is this, that means tangent is going to be 12/5. Okay, so then we say that first of all, we say input solution. Okay, cot theta is is equal to 1/tan theta. Therefore, if cot theta is equal to 5/12, then tan theta is equal to 12/5. All right, so let's draw our normal right angle triangle to solve this. Very fast, right angled triangle. Okay, let's say here is my reference angle theta. Now we are given tan theta, which is 12/5. All right, so at this point, remember that tan theta, recall that tan theta is equal to opposite over adjacent. Okay, that means here is opposite, here is adjacent. We're going to find hypotenuse. Now, to find hypotenuse, let me first call here x. The formula says s squared is equal to 12 squared plus 5 squared. This is Pythagoras theorem. So I have s squared, 12 squared is equal to 144, 5 squared is 25, then s squared. Now this is going to give me 169. Therefore, my x is equal to square root of 169, and that is equal to 13. That means x is 13, and the x is hypotenuse. That means here is equal to 13. All right, now let's continue. Let's solve these ones then. Sine theta becomes what? Now sine theta is equal to opposite over hypotenuse, which is equal to 12/13. 12 over 13. Then sine square theta is equal to 12 over 13 all squared, which is equal to 144 over 169. All right, so that means sine square theta is equal to this. You can see break it down if there is anything that can divide both numerator and the denominator. So that is that for that. Now let's check the second one. II says cos theta minus sin theta. Now we have gotten, what's it called? This is my sin theta now. Okay, now to get my cos theta, now cos theta is equal to adjacent over hypotenuse, okay, is equal to 5 over 13. That means I'm going to replace this with this, replace this with this, okay. So I'm going to have 5 over 13 minus 12 over 13, which is equal to, common LCM is 13, okay. I'm going to have 5 minus 12, which is minus 7 over 13. That is that. Let's look at this particular one, this very one. Let's look at it. The third one, 1, 2, 3. Third one says cos theta plus sin theta all over cos theta minus sin theta. Cos theta is 5 over 13. Sin theta is 12 over 13. Okay. What again? Repeat the same thing. Okay, this is plus. Pardon me, please. Something is being repeated here. I'm going to have 5 over 13, but here is minus 12 over 13. Okay. If I should work on this, I'm going to have 5 plus 12 to be 17 over 13, the common LCM. Now over the one under, what is here is what is here. So this gave us this, okay? So I'm going to have minus 7 over 13. So from here now we'll continue. So 17 over 13, this is something like saying 17 over 13 divided by minus 7 over 13. Something like saying 17 over 13, all right, multiply by inverse of this. The inverse becomes minus 13 over 7. Okay, good. Now, this becomes 17 times minus 13 all over 3 times 7. Okay, now let's multiply these two. Let's multiply. Okay, now 17 is multiplying minus 13. Okay, let's go this way. 7 times 3 is 21. Okay, let me put it this way. 7 times 3 is 21. I write 1, carry 2. Then 7 times minus 1 is minus 7. Okay, or meanwhile, I just remove this minus for now, then add it at the end of the whole multiplication process. So 7 times 3 is 21. I write 1, carry 2. 7 times 1 is 7 plus 2 is 9. Now, what again? 1 times 3 is 3. Okay. This gives us minus 221 over 21. Okay, now at this point, let me leave this with you. Let me stop it here. I would like you to actually go further to see if there's a way to break this thing down to a simpler form. Please try it and let me see your work. Thank you very much. Bye for now.